This video covers the main risks that you will encounter when working in the NMR facility. You should watch all of this video before entering an NMR lab or using an NMR spectrometer in the chemistry building. Before using the NMR facility, you should be aware of several safety concerns and make sure that you can identify the risks associated with working in an NMR laboratory. The first risk that we will cover is that of strong magnetic fields. An NMR spectrometer uses a very strong superconducting magnet. The magnet is positioned in the center of a large cryostat, but the magnetic field usually extends beyond the walls of that cryostat. This means that to use the NMR spectrometer, you may have to enter an area which contains a strong magnetic field. There is a line drawn on the floor indicating 5 Gauss, and you should not cross this line with any magnetic items such as spanners, keys or coins, as they can be attracted to the magnet and damage it. You must stay outside the line if you have a pacemaker or any metal implants, unless you have permission from your doctor and have shown that permission to a member of staff in the health and safety team or the NMR facility. You are advised to leave any bank cards, mobile phones or watches outside the line, as they can be irreversibly damaged by the magnetic field. The second risk that we'll cover is that of cryogenic materials. The cryostat of the NMR spectrometer is like a large thermos flask. There can be up to 100 litres of each cryogen inside an NMR spectrometer. If these were to boil off in a single burst, it is likely that they would replace all of the air in the NMR laboratory with nitrogen and helium gas. This would mean that there were no oxygen available in the room, so the risk of asphyxiation would be very high. This will occur if the vacuum on the cryostat is compromised or the magnet ceases to be a superconductor, known as a quench. If the NMR cryogens boil off rapidly, you will usually hear a pop as a pressure valve at the top of the magnet opens. You will then hear a whoosh as supercooled gas starts to be released. A cloud of cold helium gas will start to form at ceiling height, and a cloud of nitrogen gas may start to form at ground level. If you witness a quench, you should quickly leave the room, alerting any other occupants as you do so. Oxygen depletion sensors are located in every NMR laboratory in the chemistry building. Sensors are positioned 4 feet and 8 feet from the ground and will activate an alarm when the oxygen level in the room drops to 18.5% or lower. However, if you are in the laboratory, it is unlikely that the alarm will start to sound before you notice the gas clouds from a quench, and you should not wait for the alarm to sound before evacuating. The chemistry building oxygen depletion alarm has 2 components: a loud continuous beeping alarm and a red beacon which flashes inside and outside the entrance to the laboratory. If you hear the alarm or observe the flashing light, you must not enter the laboratory. If you are in the laboratory and you witness a quench or the alarm starts sounding, then you should make your way out of the room, alerting anyone else who was in the room as you leave. Close the door behind you. You should inform a member of NMR staff that the alarm has been activated. If you are working out of hours, you should contact security. It takes only 2 breaths of low oxygen atmosphere to render a person unconscious, so you must not enter a laboratory if the alarm is going off, and you should not go to someone's aid if they are unconscious in the laboratory, as you are unlikely to be able to rescue them. The third risk that we will cover in detail is that which causes the majority of injuries in an NMR facility. This involves the use of NMR tubes. NMR tubes are made of very fine glass and can easily break. They are also transferred from chemical laboratories, so are likely to be chemically contaminated. Before you bring an NMR tube into the NMR laboratory, you should check that it is safe. The tube should be free from breaks, cracks or scratches. It should be clean on the outside and should be capped with a secure lid. When handling the tube, you should keep your hands close together, as this reduces your ability to apply strong forces to the tube. Use a dedicated gauge to position the NMR sample in a spinner at the correct height. Gently press it into the spinner, holding the sides of the tube rather than pressing on the end. Do not force the tube into the spinner as it will break. Before placing the spinner into the spectrometer carousel, wipe the tube with an IPA-soaked tissue to remove grease residue that may have transferred from your fingers. After wiping, check the position again and only handle the tube from the top from now on. The tube should be labelled with the initials of the principal investigator, the initials of the user, and a reference to the laboratory notebook which details the contents of the NMR tube. If there is space, you can also record the solvent. If a label is used rather than a marker pen, then this should be secure and fastened all the way round without forming a flag. An appropriate chemical risk assessment should be in place for the sample before bringing it into the NMR facility. Should the tube break in the facility, you will be required to provide the chemical risk assessment to NMR staff. If your sample contains a substance which is so dangerous that the NMR facility would have to be closed if the tube broke, then you should not submit your sample to the walk-up NMR systems. In this case, please contact a member of NMR staff for assistance in submitting your sample. There are additional risks in the NMR facility relating to the use of sample changers. Sample changers have parts which move rapidly and can catch and break fingers and hair easily. If a sample changer is in motion, you should wait until it stops before adding or removing a sample. You may need to climb steps to submit samples to the NMR spectrometers. You should check the steps are stable and suitable before using them. In addition to this online training, you must complete a risk assessment for running samples in the NMR facility. A pro forma risk assessment is available from the NMR service website and the school health and safety website. If you have any questions, you should direct these to a member of NMR staff before using the NMR facility.